Alright, you guys, we're going to talk about, to me, one of the most important lessons in geometry, which is using Soh Cah Toa and basically learning how to do trigonometry. And Soh Cah Toa is the Indian guy, and his name is called Soh Cah Toa because the S stands for sine, the C stands for cosine, and the T stands for tangent. And what these are, they're ratios. And this tells you we have O for opposite and H for hypotenuse. And A stands for adjacent and H stands for hypotenuse. And O stands for opposite and A stands for adjacent. And so if you can remember Soh Cah Toa, you can remember that the sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now what do I mean by these things? I chose angle A. So we're going to mark the angle we're working with. Here's my angle A. And we are going to then label the sides according to the relation to the angle. So label the sides in relation to the angle you're working with. Label the sides in relation to the angle you're working with. I'm working with angle A. I always start with the opposite side of the angle. So when you go straight across, you have O for opposite. Then I always know what the hypotenuse is. H, this is my hypotenuse. Whatever side is left is A, my adjacent side. So I have opposite, hypotenuse, and adjacent. Opposite, hypotenuse, and adjacent. So, for example, if I asked you to find the sine of angle A, well, this is a ratio, and according to Soh Cah Toa, I'm looking for the opposite side over the hypotenuse side. So my opposite side, O, is 5, over my hypotenuse side, H, which is 13. I'm done. I just wrote the ratio for sine of A. What is the cosine of A? Well, cosine is equal to adjacent over hypotenuse. So adjacent A over hypotenuse H. And that's my ratio for cosine. And I can do the same thing for tangent. The tangent of angle A is equal to opposite over adjacent, OA, TOA, opposite over adjacent. So my opposite is 5 over adjacent, which is 12. And that's it. All I'm doing is finding ratios. You always take sines, cosines, and tangents of angle measures, and the sine, cosine, and tangents of those angles is equivalent or equal to the ratio of the sides. Now be careful. You could do the same thing. I could ask you then, okay, what is the sine of B? Well, where is angle B? Angle B is right here. What do I need for sine? Well, I need the opposite and the hypotenuse. To angle B, this is my opposite side, and this is still the hypotenuse. So the sine of B is 12 over 13. And so the ratios will change depending on what angle you're working with. That's why it's important to label in relation to the angle you're working with, because the opposite side can change depending on which angle you're dealing with. Okay, let's do some problems using trigonometry. We're going to find the missing sides. To measure the height of a tree, Alma walked 125 feet from the tree and measured a 32-degree angle from the ground to the top of the tree. Estimate the height of the tree. This is what I'm trying to find. Alright. However, you have to first identify your sides based on the angle you're working with. So first, identify your sides. Okay, here's the angle I'm working with. When I go straight across, this is my opposite side. This is the hypotenuse, and this is the adjacent. The hypotenuse has no numbers, no variables. I'm not working with this one. So, second, identify which trig ratio to use. I spelled which wrong. Okay, I'm dealing with O and A. Now here's the name. So, O and H? No. Cah, A and H? No. Toa, O and A? Yes. T stands for tangent. So, tangent, I just identified which trig ratio to use. Now, third thing we have to do is write the equation. Now don't forget, you have to take sine, cosines, and tangents of angles. So the angle I'm dealing with is 32 degrees. So the tangent of 32 degrees is equal to the tangent ratio of opposite over adjacent. So I'm dealing with x over 125. Now we're going to solve the equation. Now this is an algebra equation. You're going to solve it for x. Right now x is being divided by 125, so to solve it I'm going to multiply both sides by 125 to get my x by itself. Now here's where you have to take your calculator out. Your calculator will by default put a parenthesis. It just automatically inserts a parenthesis. You must end your parenthesis. So you're going to type in your calculator 125 times the tangent of 32. And when you type in 125 times the tangent of 32, you will get a decimal. And unless it tells you which way to round, you always round to 1 decimal point. So if I do this on my calculator, I should get 78.1. Label is feet. So the tree is about 78.1 feet tall. Okay, we're going to do it again. This time we're given the angle and I have to identify my sides. First, identify your sides. So to this angle, this is my opposite side, this is my hypotenuse side, this is my adjacent side. I'm not dealing with that hypotenuse. O and A means tangent. O and A means tangent. That's my Toa. So remember, Soh Cah Toa. O and H? No. A and H? No. O and A? Yes. T for tangent. So I write tangent of the angle I'm working with, which is 40. It's equal to opposite, which is x, over adjacent, which is 62. We're going to solve this again by using algebra. I'm going to multiply both sides by 62 in this case and type this into our calculator. Don't forget, the calculator adds a parenthesis. You must end your parentheses. So you're going to type in 62 times the tangent of 40 degrees. And if you do this right, you should get about 52.0. Alright, the next example is interesting because you're going to run across a different type of algebra equation. The setup is the same. Here's our angle. We're going to identify the angle we're working with. This is my opposite side. This is my hypotenuse side. This is my adjacent side. Not working with hypotenuse. O and A means tangent. So I have tangent of the angle is equal to opposite over adjacent. Now this is different. the x is on the bottom. When the x is on the bottom, you switch. You take these two things and you literally switch places. So this is my new equation. X equals 90 over the tangent of 72. This is a division problem, not a multiplication problem. Don't forget, you have to end your parenthesis. So please type in 90 divided by the tangent of 72, and we should get our answer. And if you did this correctly, x should be approximately 29.2. And you have your answer. Okay, we're going to do another one. So we're either going to multiply or we're going to switch. Multiply or switch. When the x is on top, you multiply. When x is on the bottom, you switch and then divide. Alright, let's do another example. A 20-foot wire supporting a flagpole forms a 35-degree angle with the flagpole. To the nearest foot, how high is the flagpole? This is what I'm trying to find. First, identify your sides. This is my opposite side. This is my hypotenuse side. This is my adjacent side. There's no variable or anything working with the opposite side. I'm working with A and H. See, so, no, Cah, yes, A and H. Cah means cosine, so I write cosine of the angle, and the ratio is adjacent over hypotenuse, x over 20. Now I have to simply solve this. This time the x is on top, so to get it by itself, I multiply both sides by 20. Different trig function, same way to type it into the calculator. Make sure you end your parenthesis. Please type in 20 times the cosine of 65, or excuse me, 20 times the cosine of 35. Now what you get is this, 16.4, but it's said to the nearest foot. This is a fancy way of saying no decimals. The nearest foot means no decimals. So my cutoff is here. The 4 does not do anything with the 16, so x is approximately 16 feet. Alright. I want you guys to, on your own, turn your paper around and try exercise 3 and 4, finding x to the nearest tenth and finding y to the nearest tenth. Go ahead and put the video on pause, unless you don't want to wait, because I'm going to go ahead and do the problem, and I want you to compare and contrast your answers. Okay, for this 57, this is my opposite side, this is my hypotenuse side, and this is my adjacent side. So let's find x first. X is the opposite, and I'm given the h, the hypotenuse. O and H is so. That means I'm dealing with sine. So I'm going to do sine of the angle, which was 57 degrees. The sine ratio is opposite, x, over hypotenuse, 25. So there's my equation. To solve this, I'm going to multiply both sides by 25. X is approximately, now nearest tenth means 1 decimal point. So if you do this correctly, or if you did this correctly, x should equal approximately 21.0. I'm going to do the same thing for the y. Now I've already have it labeled. Y is the adjacent side, and I'm given hypotenuse. So, no. Cah, adjacent hypotenuse, yes. Cah means cosine. So I'm going to do cosine of the angle and set it equal to my adjacent side over my hypotenuse. Solving this one, typing it into the calculator to the nearest tenth, you should have gotten y is approximately 13.6. Okay, now what we're going to do is use inverse functions to find angles. We use inverse functions to find angles, and by the way, to get these buttons you have to use the second button and then sine, cosine, or tangent. If you look above your sine, cosine, and tangent buttons, you will see these inverse -1s as exponents. Alright, let me demonstrate how we're going to use these. Find the measure of angle R to the nearest degree. So since I'm trying to find angle R, I'm going to go ahead and mark it. This is the angle I'm trying to find. And I'm still going to identify my sides. So going straight across, this is opposite, this is my hypotenuse, and this is my adjacent. I'm not doing anything with the hypotenuse. O and A. So, O and H, no. Cah, A and H, no. Toa, O and A, yes. I'm dealing with tangent. So I write tangent of the angle. Now this time I don't know the angle, so I'm just going to call it R, is equal to, the ratio is opposite, 47, over adjacent, 41. Now, we've never had this kind of problem where we've had to find the angle. So I want to get the R by itself. So what I'm going to do is take this tangent function and move it to the other side by taking its inverse. So R is equal to the tangent inverse of 47 divided by 41. So you're going to literally type in second tangent. The calculator puts in a parenthesis, you type in 47 divided by 41. Be sure to end your parenthesis. It's very important. Very important. End your parenthesis. Okay, type this in. Now it says to the nearest degree. This means no decimal points. You're going to round your answer. So if you do this right, R should be 48.9. This 9 makes it go up. So the measure of angle R is approximately 49 degrees. And I'm done with the problem. Okay, let's do this example. Notice they didn't give us a picture this time. No picture. So draw a picture. A right triangle. I'm going to draw a right triangle. Has a leg 1.5 units long, hypotenuse 4 units long. Find the measures, notice it's the letter S, of its acute angles to the nearest degree. Now, which ones are the acute angles? This is the 90-degree angle. These two angles are acute. Let's call this angle A. Let's call this one angle B. Okay, we're going to start with A. To angle A, this is my opposite, this is my hypotenuse. O and H, O and H, sine. Sine of angle A equals opposite over hypotenuse. To solve this, we move this trig function over. A equals the inverse sine of 1.5 divided by 4. So, type this into your calculator. A is approximately 22 degrees. All right, let's find B. Here's angle B. This side is my opposite. This time I'm not using it. This is my hypotenuse still, and now this is my adjacent. It's a different function, dealing with adjacent and hypotenuse. So now I have cosine of B is equal to adjacent over hypotenuse. We're trying to find the angle, so we're going to take the inverse. B is the inverse cosine of 1.5 divided by 4. Type it into your calculators to the nearest degree. You should get about 68 degrees. Now here's a great way to check to see if you're right. Add your two angles. They should be complementary. These two angles should be complementary. In other words, they should add to 90 degrees. Do they? Find out. 22 plus 68? Yep, they do add up to 90 degrees. Okay, last problems. I want you to try 5 and 6. You try 5 and 6. An interesting thing happens with 5 and 6. It says find x. Well, let's start with x. This is the opposite. This is the hypotenuse. And this is the adjacent. Like, wait a minute. How do you know which trig function to use? Because you have all three numbers. Well, here's the beautiful thing. You pick any trig function to use. You get to choose. Do you want to use sine, cosine, or tangent? Your choice. I choose sine. Sine of the angle x is equal to opposite, which is 60, over hypotenuse, which is 87. So I'm going to solve this. X equals the inverse sine of 60 divided by 87. If I do this correctly, x is equal to about 44 degrees. Now, do I really have to use my calculator to find the value of y? Do I really have to? No, because if I found x right, I know x and y have to be 90 degrees. And I know x is 44. So if I subtract 44 from 90, I get my y. So 90 take away 44 is 46 degrees. You don't always have to use trigonometry. Alright, you guys, I have practice for you guys. Here's your homework. This is section 4.3. And this is actually section 4.4. This works mostly with tangents. And this works mostly with cosines and sines, just so you know. But you can do it any way you want. If you want to use cosines and sines for these, go ahead. If you want to use tangents for these as well. It's all trigonometry. So good luck, have fun, and have a fabulous day.